Matter, Elements, and Atoms from Khan Academy. Introduction. What is your body made of? Your first thought might be that it's made up of different organs, such as your heart, lungs, and stomach, that work together to keep your body going. Or you might zoom in a level and say that your body is made up of different types of cells. However, at the most basic level, your body, and in fact all of life, as well as the non-living world, is made up of atoms, often organized into larger structures called molecules. Atoms and molecules follow the rules of chemistry and physics, even when they're part of a complex, living, breathing being. If you learned in chemistry that some atoms tend to gain or lose electrons or form bonds with each other, those facts remain true even when the atoms or molecules are part of living things. In fact, simple interactions between atoms, played out many times and in many different combinations in a single cell or larger organism, are what makes life possible. One could argue that everything you are, including your consciousness, is a byproduct of chemical and electrical interactions between a very, very large number of non-living atoms. So as an incredibly complex being made up of roughly 7 billion trillion atoms, 7 times 10 to the 27th, you'll probably want to know some basic chemistry as you begin to explore the world of biology and the world in general. Matter and elements. The term matter refers to anything that occupies space and has mass. In other words, the stuff that the universe is made of. All matter is made up of substances called elements, which have specific chemical and physical properties and cannot be broken down into other substances through ordinary chemical reactions. Gold, for instance, is an element, and so is carbon. There are 118 elements, but only 92 occur naturally. The remaining elements have only been made in laboratories and are unstable. Each element is designated by its chemical symbol, which is a single capital letter, or, when the first letter is already taken by another element, a combination of 2 letters. Some elements follow the English term for the element, such as C for carbon and Ca for calcium. Other elements' chemical symbols come from their Latin names. For example, the symbol for sodium is Na, which is a short form for natrium, the Latin word for sodium. The 4 elements common to all living organisms are oxygen, carbon, hydrogen, and nitrogen, which together make up about 96% of the human body. In the non-living world, elements are found in different proportions, and some elements common to living organisms are relatively rare on the Earth as a whole. All elements and chemical reactions between them obey the same chemical and physical laws, regardless of whether they are a part of a living or non-living world. The structure of the atom. An atom is the smallest unit of matter that retains all of the chemical properties of an element. For example, a gold coin is simply a very large number of gold atoms molded into the shape of a coin, with small amounts of other contaminating elements. Gold atoms cannot be broken down into anything smaller while still retaining the properties of gold. A gold atom gets its properties from the tiny subatomic particles it's made up of. An atom consists of 2 regions. The first is the tiny atomic nucleus, which is at the center of the atom and contains positively charged particles called protons and neutral, uncharged particles called neutrons. The second, much larger region of the atom is a cloud of electrons, negatively charged particles that orbit around the nucleus. The attraction between the positively charged protons and negatively charged electrons holds the atom together. Most atoms contain all 3 of these types of subatomic particles: protons, electrons, and neutrons. Hydrogen is an exception because it typically has 1 proton and 1 electron, but no neutrons. The number of protons in the nucleus determines the element an atom is, while the number of electrons surrounding the nucleus determines which kind of reactions the atom will undergo. The 3 types of subatomic particles are illustrated below for an atom of helium, which by definition contains 2 protons. So as you can see here, we have the structure of an atom. The protons, positive charge, and neutrons, neutral charge, are found together in the tiny nucleus at the center of the atom. The electrons, negative charge, occupy a large spherical cloud surrounding the nucleus. The atom shown in this particular image is helium, with 2 protons, 2 neutrons, and 2 electrons. Protons and neutrons do not have the same charge, but they do have approximately the same mass, about 1.67 times 10 to the negative 24th grams. Since grams are not a very convenient unit for measuring masses that tiny, scientists chose to define an alternative measure, the Dalton, or atomic mass unit, AMU. A single neutron or proton has a weight very close to 1 AMU. Electrons are much smaller in mass than protons, only about 1/1800th of an atomic mass unit. So they do not contribute much to an element's overall atomic mass. On the other hand, electrons do greatly affect the atom's charge, as each electron has a negative charge equal to the positive charge of a proton. In uncharged neutral atoms, the number of electrons orbiting the nucleus is equal to the number of protons inside the nucleus. The positive and negative charges cancel out, leading to an atom with no net charge. Protons, neutrons, and electrons are very small, and most of the volume of an atom, greater than 99%, is actually empty space. With all this empty space, you might ask why so-called solid objects don't just pass through one another. The answer is that the negatively charged electron clouds of the atoms will repel each other if they get too close together, resulting in our perception of solidity.